haven't post yet. Kaviwat, where is Kaviwat? Okay. So I will check name from this นะคะ It's nice to meet you. Oh. I will remember everyone from now. Do we need to break? Normally you break or not? Break ไหมคะ Break. Okay, let's break for 10 minutes. And I think today will not be late. Okay. So now we will start for the introduction of location-based service technology. Right? So the course objective, I actually explain you the scope overall that will divide two core knowledge, right? Including LBS technology, so you learn how to have comprehensive knowledge about LBS technology regarding the real-world applications. Some of you asked me for a mini project, like, so you might create some kind of mock-up which implement from Figma or in any software. You can do mock-up for the application, right? You will make the web app or mobile app or even for only spatial analysis. But if for analysis, it means that you have to choose the method for analysis, right? How to do spatial analysis. When I teach you, you have more knowledge or more ideas about it. And also you need to interpret the result, like what statistics provide or what finding you find from the analysis regarding the locations. Right? And next, we will learn about the digital mapping, geographic information system, and the integration from LBS technologies. You will use GNSS, Global Navigation Satellite System, and alternative positioning technique to measure the positions. And another technique like outdoor positioning, location of things, or augmented reality and navigation system. So I have explained you in each week that what you're gonna learn for this. Right? So the emerged mobile computing application is a core knowledge for LBS applications. It's often know where things are physically located. Okay. If we know that's where things are typically located, we can do mapping. So the mapping is the initial source to be the input in your application or LBS applications. It can be know the direction or even interact with any IoT device, and you will get to know the information, for example, traffic congestion or navigation route, how long you get there, how much time does it take to get to the destination. So the first technology that you're gonna learn, we use digital mapping. Okay. So the digital mapping is the base knowledge that need to be accurate and complete. The location technology will deliver high performance mapping and information service. Mapping is mean you can see that each layer is very complicated. For example, in Google Map, right, or Bing Maps or any other map that you see online or in the application, we call overlay mapping. Overlay mapping is mean you need to prepare individual layers. Individual layers mean each layer will have the specific or particular symbology. The symbology divided into three characteristics. The first one is point symbology. So the point symbology will contain one dimension of the data, which is contain latitude and longitude or coordinate. However, if we have more than two coordinates, it can be connected from one node to another node, will become the line symbologies. So it can be represents the river or the road or the railway that overlay on the map. And another one we call polygon. polygon or the area that can be referred to the area such as football court or water body or the area that close the coordinate, right? So for the area, we start with x1, y1. It means latitude and longitude for the first coordinate until x1, y1. Because the starting point and the end point should be the same point, right? For the area. That's why you can feel the color inside with crossing area. So this one will be overlay together. If you have 10 data or 100 data, final map you will have your application. For example, you want to show the COVID-19 map. Of course, the data can be COVID case, right? COVID case. And another one can be boundary. We call bounding box, right? So if you want to see how much density of the COVID case within the country, you have BB or B box according to the provincials or the country around the world. So it will be different layer like this. We call digital mapping. Okay. So before we create the digital map, we need to know the locations. As I mentioned that the Earth is become like as a sphere, and it's not rounded. It's not rounded because of topography. They always have like high elevation, low elevation, according to the mean sea level. So on the Earth's surface, it's not flat, it's large, right? So our duty is to unfold the Earth's surface into the flat map. This is called location or coordinate. So the map is only a model that refer from the Earth. Okay. How to unfold the data into the flat map? How to unfold the data into the flat map is can be unfold, right? It can be unfold, and it needs to be distort also. Distort is mean by it. We cannot make the model from the flat map similarly to the curve of the Earth 100%. Cannot be 100% similarly because we transform from the curve into the flat map, right? However, we need to maintain accuracies. Accuracy in terms of direction, shape, area, and the distance. So since we unfold the data into the flat map, we will construct the graphical, or we call the grid. The grid will be parallel and vertical line. And after that, we define the coordinate. Like for example, this is 13 and 100 something latitude, longitude. Okay. So this is the process to transfer from the Earth into the flat map and construct coordinate system. Okay, so since we get the digital mapping, there's a few technology that I would like to introduce you. Consists of 4 technology we call geoinformatics. Geoinformatics is about of information related to geography or geographic information systems. The core knowledge of geoinformatics including remote sensing, which is measured from the satellite image. Okay, so it can be returned as a base map in our applications. Right. And the next technology is global navigation satellite system. We talk to satellite communication satellites, which is surrounding in the atmosphere. Right? However, the limitation need to measure from the outdoor, right, or in open area. So since we talk with the communication satellite, we will get XY calculated from our distance, calculated from our location, the user location to the satellite positions. That's why we know XY or the coordinate. Right? And since we get coordinate, we need to deal with the spatial data. Sometimes it have bias. Sometimes we get signal loss. Sometimes we have not accuracy database like point line polygon are missing due to not update in the database. That's why I need to handle or manage the spatial database. And the last technology we call Geographic Information System. We apply this GIS to analyze the data. So from this one, you have idea how to engage with the data science to analyze the spatial data as well. All of technology we call the group of geoinformatics technologies. And for the spatial database, I think you have learned about the database already, but we normally use Postgres SQL because it can be used PostGIS as well. The PostGIS is extension of Postgres SQL, which can be handle spatial database. Right? So you can even query, update, and map into Postgres SQL, and then link this kind of database into the web map. So every time that you update in the field survey, the map can be updated in the database, and then the website also update as well. So the database is stored and query data related to the object in the space, including point, line, polygon. As I mentioned, that point is XY, right? So XY will be one of the column in the database, right? XY, coordinate, latitude and longitude. From this one, we can map into the digital mapping. This can be linked to each other. But if the line is mean that you have x1, y1 until xn, yn, right? So it can connect to each other like this. So the database is depend on what kind of symbol you can create, right? The polygon as well. If the polygon you will, in your database, you will have x1, y1 until x1, y1, right? My skin is not beautiful anymore until x1, y1, right? So this is the crossing area or the polygons. Okay. So the objective is how you design the database, and then from the database can be mapped into your application or LBS applications. This can be one of your mini project as well. And I think you can search this particular data, put into the spatial database and map them, and then implement in the application. I just want to see your idea, how you design like UI, how you create the spatial data, how you do the analysis until the application can be used effectively. Okay. So since we have the database, can do the location analytics as well. Location analytics, we want to extract more valuable insights the data. Okay, valuable insights the data. For example, densities, clustering data, or even you can buffer. For example, this is the center of highest magnitude that can be happen the earthquake, right? You can create a buffer like this. We call buffer in certain distance. That how far your village stay nearby the earthquake or the disaster. It means that if there are some village here nearby the center of the earthquake, it will get the most effect, right? Or it will be collapse or most risks. This one we call buffering. Or even you can do risk analysis. So not only do analysis, but we need to design for visualization in order to provide the system to the user to understand our application perfectly. Even you do like a lot of analysis, machine learning, modeling, predictive analysis, but you cannot design the visualization in your application well. User will not understand, right? And they cannot use our application well as well. So everything needs to be linked together effectively. So after the location analytics, you can deploy your data using the visualization, right? So if we see from this graph, the graph is show time versus data accessibility. So nowadays we become the era of mobile LBS, right? So the mobile LBS, you can use any mobile device linking with outdoor or indoor location technology, and the user can access the data perfectly and accurately. So this is from the development, and it's growing up with the technology and network technology as well. In the beginning, we just have like GPS. I can say compass. In the beginning, we use compass, right, for the direction and navigate. Right? So since we have GPS, we can know the exact locations of the object that locate on the Earth's surface. And now we have so many group of GPS or navigation satellite we call global navigation satellite system, which is high accurately. Position. Even in millimeter. In millimeter is mean very accurate, right? Very accurate position. But for GPS, sometimes can be missed like 15 to 30 meters. 15 to 30 meters. That is possible to have accidents. Like, for example, if you have the road like this and you drive below the BTS station or BTS route, right? If it's biased or if its major position shift to 15 to 30 meters, it means that it can be dangerous, right, for the navigations as well. So now we get really high accuracy position already. However, this is depend on the cellular network also. If you use mobile phone, right? If you use mobile phone, even even if have high technology, but if your cellular network doesn't work, it means nothing, because we have no network to connect with the GPS. Okay. I will post this video to introduce to you how it is location-based service. No? So the definition of the location-based, you can see that we have GIS, spatial database. So in this circle, we will make the digital mapping. And connect with the internet technology and any mobile device. This is intersects together to be LBS or location-based service applications. So the main idea is collecting geodata. So now before it is difficult to collect geodata because only like a specific organizations or only people who work with the geospatial data can get or acquire the data. But now you can even search from the internet. You can scrape data. You can connect with the API or even use AI to help you to implement the software. Right? So together with the real time using one or more location tracking technology, I can say that even not real time, near real time, still we can call location-based service because sometimes we don't need exact real-time location data, right? But okay, only update data for us, update the risk for us. So it means that we can make the decision from our application, particularly regarding to the spatial. Right? So spatial is spatial. Spatial is mean place. Spatial is mean place. But if you concerned about the time as well, we can say spatial plus temporal. Temporal is mean time. So if we indicate together, we call spatio temporal analysis. So not only the place, but the dynamic of phenomenon as well. Okay. For example, your analysis, you can be the data, for example, agriculture precision. Okay. So if you make some kind of application that can be fertilizing automatically in your farming, right? So you can even track the growth of your paddy field. Like you detect the color from paddy field, right? Green color, yellow color, and harvesting stage. So this one we call temporal. You don't need to go into the field. You can say the farmer or monitor near real time, distantly. So in remote area or like no need to do the field survey, but you can track this kind of phenomenon, temporal analysis. Right? So you can help farmer to make the decision that okay, this one or this time, this month, you need to be harvest already. And if you have like 10,000 tare of sugarcane. The farmer don't need to go into the field and monitor by themselves. You can deploy the IoT camera, write some algorithm, detect image processing, and then some field or some plot already need to be harvested. Then you can tell the farmer go and harvest it. So this is called agriculture precision. Okay, so the LBS is about not only positioning and navigation. It can be equipped with everything that can be mapped and help them to make the decisions. Okay, such as security, safety, when criminal or disaster, volcano, or even forest fire, right? Forest fire. You can fly drone and using thermal wave range or thermal channels. If you remember, I told you that normal image is RGB image, right? But for drone data or the satellite data can also detect like thermal image, infrared image, and any other wave range that can take a picture, detect the smoke, or detect the hotspot area. And after that, it can send to the application that, okay, now it's like going to have the forest fire or the fire still be burned. So this is need to see and monitor near real time or real time, right? Okay. So what location-based can contribute to tracking people or animal using RFID, right, with your cat. And when they go to another home, you can track that where's your cat to go to that place or in your neighbor, right? Even fleet management or vehicle tracking, it can be safe fuel as well, right? You can find the shortest route, help to find the shortest route. So the route can be efficiency for fleet management or logistic management or even tourist guides system, navigation system and service, finding lost and stolen objects using week1 or RFID, right? Or even indoor. Indoor you can track. You can help doctor to see that what room has emergency, right? Or we can help patients to go somewhere within the hospital, or even can use in department store. For this one, maybe last year, one of your senior doing about the disability people, help them to navigate inside the department store or in the airport. They can use indoor mapping to navigate inside the hall, inside the room, between the room, or even different floor navigation. So since we have GPS, as I told you that in our 1980s eras, now we have until 5G already. So it depends on cellular network as well, as I mentioned, not only for the GPS. So if every smartphone or every technology can be worked effectively, it can return the location and help user to make the decision perfectly. And not only for smartphone, wearable device like Google Glass, the watch, or necklace ring that can track the locations can use for the LBS application as well. Right? So the component can be divided into three components. The first one is localization. The localization we will use positioning technology. So the positioning technology is a combination with multiple technologies such as GPS to making the map, right? Or even Wi-Fi, Bluetooth can make 2D map or the floor plan. Floor plan is mean the map inside the room, the map inside the buildings. So not only we map the location, point, line, polygon outside, but we can also map inside the room as well. For example, where is the CC camera? Where is the speaker? The teacher table? So even in this campus, you can also implement your location, right, to help students and navigate students to go some of the lecture room, laboratory room as well. And another component is service provider. Right? So you need to equip with the software application along with all data that required of the service. And the last one is communication network, including Wi-Fi, user interface, which we have in smartphone, wearable device or computers. So from this architecture, I would like to show you the overall picture that if we have global navigation satellites, it's very high in the atmosphere. Okay. But one thing is different with the satellite. Observation satellite is different. Observation satellite that we use from the base map is not communication satellite. So the observation satellite have lower altitude than communication satellite. Communication satellite is very far. Even I think, if correctly, 22,000 kilometers from the Earth's surface. Okay, and so many satellites can be detected. So we have the data processing server in the cloud station as well. And after that, if you do the computing or computation and then send to the terminal for the user. So this architecture means that we have acquired from the GPS outside, sending the data to cloud station and then exchange the data via the internet. The software provides the user interface, right? We use the device to request and respond to technologies. So this is LBS platform architecture. And how location work. Actually, we mainly focus on outdoor, as I told you. So global navigation satellite system or GPS, GNSS, right? However, our mobile phone, we use a GPS, networked assist GPS. So it means that we calculate the distance, we navigate the distance from the tower, fixed tower. So if you are in the mountain, you have less tower, right? Your signal will be low. You can only track your location, but will not be much accurate. But if inside the city, you have a lot of fixed tower or fixed station like AS, DTAC, True, right? That's why you can navigate your position accurately. We call AGPS or assist GPS from the device. So the device, our device, calculate the distance from the tower first. That how many meters from AAS tower. And then this tower will talk to the GPS or GNSS satellite to know the locations. So we move, right? But the tower are fixed. The moving object we call rover. The tower we call fixed or base station. So we will teach you deeply how to calculate the distance from the fixed base to the rover again, but this is a concept of a GPS. We not directly talk to the GPS, but we talk to the tower, and the tower know the fixed location already. Okay. So a GPS determines the location information from the network station. Okay. So the base station or the fixed station, we know the position, right? Information from the signal transform into the distance technique. Using obtain distance, the device and base station can be calculated, right? So from this picture, if you stay nearby a lot of tower, you will know your position accurately. This is called a GPS. Okay. However, it depends on the geographic range. So you measure from the global, regional, or even indoor. So there are different type of network and web service required according to your geographic range. Outdoor or indoor, which device suitable to use outdoor, and even if indoor, if you have local area network, wide LAN, right, or wireless sensor, you can even choose different communication network in order to request and respond your data. Okay. So if indoor, this one we call floor plan, but it's graphic. Actually, it's not much formal, but the floor plan can explain you where are located, where the objects are located. And if we want to navigate indoor location, we will use Wi-Fi technology to calculate from the user the distance between user and the Wi-Fi. And then we can track the location, the route inside the floor or inside the room accurately. However, it's not accurate as compared to GPS. Okay. And it depends on the signal from the wireless as well, and also partition, right? Partition here. You have walls or not, or you have like a very big room. You have a lot of barrier or not. It's made from brick or miller. Many other factors that can be concerned about the locations inside the building, right? So the location from indoor positioning system we call proximate. Position. It means that estimate the location which in the range. Okay. We can guess where we are, and it can be navigate because it's not much huge area, right? You can know directly how to walk, how to go upstairs, turn left and turn right within the building. Okay. So the floor plan and the map, we need to correct the data first. So the data, or before we make the digital map, we need to correct point of interest. In the Google Map, when you search like SIIT Bangkadi, and it appear the node, one point like this, right? We call POI. In the terms of GIS, we call POI or point of interest. There are a lot of point interest in the database that you can create for the landmark. Okay. So you can see that before, I think Grab database is kind of weird because they don't have much POI. They can deliver wrong home, or even if you share the map when you are in front of the home, they can go from the back side of your home in another soil or another street, right? Because they have not much POI, not much database inside. Okay. But now I think they improve already. This kind of company, they have field data collection by themselves as well. So they learn from the customer, correct the point of the customer or POI of customer and update it. Okay, so the platform even can do geocoding. Geocoding is mean you search SIIT, but the software or algorithm convert it into 13 something or 100. We call geocoding. So whenever user search about the location name, it will change as much as the system can to be latitude and longitude, and then can be mapped. Right? Or even can reverse geocoding. Reverse geocoding is mean convert from latitude, longitude number into the name. Okay. And it can be navigate or proximity search. Proximity search means they can search within the buffer or in วงใน application วงใน search within area in this area. So this one can be buffer, radius, and then search that any restaurant that locate in this area we call proximity search. Okay, and also can emerging interface technology with any other device like smartphone. I have mentioned, no? Digital glasses, public display, or even mobile projector. You can implement your mini project using this one also. Like haptic device or wearable device. Even you use with elderly people to see the movement, right? Sometimes they fall down. We can use the device to measure the angle that it can fall down or collapse suddenly. You can measure from those behavior of people as well. So this one is one kind of the device that can emerge with the LBS. Another thing is augmented reality. You can carry device strap and take the picture, and then according to the location you overlay with the graphic or digital visual, right? We call AR. But this one you can use one maybe last 2 or 3 years. That AR just launched in the iPad. Your senior also using this one, but it doesn't reflect to the location, right? You only take a picture here, and it's overlay how to put the furniture inside the room. You need to implement more or design more that how it can be related to location, like finding the suitability to design the furniture inside. Not only can use the device. Okay, it means that your idea you need to implement something that help to navigate, help to find, help to search, help to proximate using the location. Okay. Or the customer and business, you can help the customer alert when the customer walking into some shop, department store, showing the or propose the discount 30% off with this code. So this one can track, right, the location of the user that they walking into that department store already. It can increase the profit of the shop or business as well.